Hey everyone, in this video let's go to question 141, linked list cycle on Leetcode. This is part of our blind 75 list of questions, so let's begin. In this question we are given the head of a linked list and we want to determine if the linked list has a cycle in it. There's a cycle in a linked list if there's some node in the list that can be reached again by continuously following the next pointer. Internally, position is used to denote the index of the node that tail's next pointer is connected to. Note that position is not passed as a parameter. I don't know why they told us about that. That's not even important to us. But anyways, you can just see here, like we have 3 and then next is this and then this and this. And you can see that -4 next goes back to 2. And then so this is our cycle over here, right? And you want to basically return true or false depending on whether there's a cycle or not. Now, there are famous algorithms to do this. Like you can just search up cycle detection algorithms. They work for graphs, they work for linked lists, all sorts of things, right? So I guess what's one way we could do it, right? Well, one way, and even before I start that, I noticed that head here is optional. So I guess if head doesn't yet exist, then we can return false, right? There is no cycle. But what is one way we could do this? Well, we would have to go through the list, right? The linked list. And maybe if we notice the same node twice, then we know that there's a cycle, right? So here, it's fine if like node's value is not necessarily unique, right? So we actually have to cache the nodes themselves. But if we notice a case where the nodes themselves repeat, then we know that we've arrived at a cycle. So because if it was just straight, then we would just end and we wouldn't have any of these cases. But if we're going back here, then we'll revisit this 2 again. And then obviously like this 0 and -4. Let's maybe start off with that approach to see if we can do it. So one thing I would do is I'll have like a curve variable, I'll set it to head. I have a scene variable, I'll set this to set. And initially what I'll just do is we want to loop until probably like the good case, right? The good case is like there is no cycle. So we just go until cur is none. So in this case, what can we check? We can check if cur in scene. If this is the case, then we know that there's a cycle because we visited this node before. So we can return false here. Or actually we can return true here, indicating that there is a cycle. Otherwise what? Well, otherwise I have to add this scene.add, and I add in cur, not cur.val, because cur.val is not guaranteed to be unique. So that's one thing. Add in cur, and then I'll basically just advance cur. And if I get through this loop without returning, then I know that I arrived at the end and that there is no cycle. So I'll go ahead and test this. And then I'll go ahead and submit. So we arrive at the answer. So this is an O of n time answer and also O of n space because we have to store the visited in a set. Now, there is one other way of doing this. And again, this is one of those like famous algorithms that are used to detect cycles. And that's probably not all that obvious, but if you think of it, think of like a track, right? Think of if I asked you to run down like a road, right? And you didn't know whether this road was track that like curved in itself, like if it was like a track, like something like this, or it was just like a straight road. And I asked 2 people to run along that road. Well, obviously one person's going to be faster than the other, right? Nobody's going to run at the same speed. But let's say there's one person that runs like significantly faster than the other person. Well, what do we know, right? If you think about this one, like if you're running and then you see the person cross you, right? And then you see them cross you again. Well, the only way they can actually cross you is if the track is curved, right? If the track is a loop, if there's a cycle. If the track is just straight, then they're not going to cross you ever. They'll just finish way ahead of you. But that's it. But if you see them like on your left, on your right, if you see them again, then you know that in this case, like there has to be a cycle because they overtook you essentially, right? It's like in a race car track, like if the car overtakes you, then you automatically know that like you're going in a loop. So that's like one thing we could do here. We could maybe think of in terms of like 2 pointers where 2 pointers represent 2 racers. So how might we do that? Well, let's just say we have cur here, and then we can have like a faster cur. So we'll just call this faster. And initially they both start off at head, right? They both start off at head. So now how do we want to loop? Well, one thing we want to do is we'll have while cur. So this first pointer, we want this to basically just advance 1 position at a time, right? 1 position at a time. But the next one, we want it to advance 2 positions at a time. What we have to make sure of is this will make sure that we can at least access cur.next. But if we want to access cur.next, like 2 positions in advance, then we also have to check and fast.next. So this will allow me to basically go from, if I'm at like 1, 3, 5, 7, and let's 1, 3, 5, 7, and let's say cur and fast both start here. This will allow cur to go over here, but it will allow fast to go all the way over here. And then luckily, if there is a cycle, then fast will eventually intersect with cur again. And that will just be the case. So if this is the case, then what can we do? Well, if this is the case, then we can advance cur. We could advance next, which is fast, but we'll do fast dot next. And if both of them are equivalent, right? If cur is equal to fast, right? But we have to check that they're not none, right? Like if both of them are none, then we don't have a cycle here. But we can check like if cur and fast, right? If both of them exist, then we can check. If cur equals fast, then what do I know? Well, then I know that there's a cycle. There has to be a cycle. Otherwise, if cur and fast exist and maybe they're like there's not a cycle, they're not equivalent, then I know that potentially there's a cycle, but maybe not yet, right? Otherwise, if we go through this entire loop without returning, then we know there isn't a cycle. So let's go ahead and try this approach. We can see it works. Let's try the example test cases. And we can see it works. Now I just submit it, and we can also see that it works. And actually not, so fast on next. So I guess I have to check while cur and fast on next. Possible that fast is actually next. Okay, cool. Yeah, so that's basically how we will get this to work. Okay, so in this one, we actually don't use any extra space, but all of one time space, and the time complexity is the same. Okay, thanks for watching.